1, 2, 1, 2. 1, 2. Okay, so good night everyone. We're going to get started shortly. We give others time to join you live. This is mine. Kevin? Oh. Ya sao chưa phải All right, so good night, everyone, and let us get started. So first, I want to apologize for last night. Last night we had just some minor technical challenges. So the live was cut short last night, but we want to continue the process tonight. The exam is tomorrow. So let us see what we can get done tonight. Let us see if we can cover all the sections. We were on section 1 last night, and we have to complete sections 2, 3, and 4. So let's see what we can get done within the time. I'm trying not to spend more than 3 hours, so let's see what we can get done. All right. Okay, so last night we would have looked at, in section 1, we would have looked at remainder factor theorem, we looked at logs, we looked at exponential equations, we got into as well dealing with quadratics, all the very important topics under quadratics, from rational inequalities, completion of squares. We would have looked at questions involving sketching of the quadratic function, also understanding how to solve quadratic inequalities, right? So we would have looked at a few topics under quadratics, and what we want to do tonight is to look at quickly. We will look at APGPs, arithmetic geometric progression, then we get into some circle theorems, sectors, vectors, trigs. We look at some differentiation, integration, and we will close off with some stats on probability. All right? So let's get into it. All right, so we want to start off first with APs and GPs, which you will see definitely in question 2 of section 1. And remember, with APGPs, so APs, well, arithmetic progression, and geometric progression. So we want to remember some key things about APs and GPs. If we're starting with the AP, the arithmetic progression, we have to remember that with all series or sequences, we must have a first term, which is denoted by A, so that's our first term. Of course, if there's a first term, there's a second, third, fourth, and so on. So our second term, our third term, all the way down to the nth or last term. So with an AP, note we will have a first term, but we move from the first to the second to the third term by adding some constant called the common difference, which we know is denoted by D. So if I add A to D, I'm going to get A plus D. If I add D to A plus D, I'm going to get A plus 2D. And my nth or last term will be denoted by A plus n minus 1D. And this very important formula here is a key formula in helping us to determine the value of the position of a given term. So this formula, which is known as the general formula, T is equal to A plus n minus 1D, keeping in mind that T is the value of the particular position of the term. A is your first term, D is the common difference, and N will be the position of the term. So if it's the third term, fourth term, fifth term, what have you. So we want to make sure we know this important formula. Likewise, for APs, we want to ensure we understand how to find the sum to n terms. So to find the sum to n terms, we use S, and the formula will be n over 2 into 2a plus n minus 1d. So we have to make sure we know this formula. Again, S representing the sum, n will be the, we want to find the sum to a given number of terms. Of course, A is your first term, D is your common difference. So we want to make sure we know these two important formulae. For the GP, on the other hand, for the geometric progression, we have to remember again, there will be a first term, there will be a second term, third term, fourth, fifth, all the way down to the nth or last term. And note, we move from one term to the next by multiplying this time that constant, which is known as your common ratio. That is denoted by R. So when I multiply R by A for my second term, that will be AR. If I multiply R by AR for my third term, that becomes AR squared. If I multiply, of course, for my nth term, that will be denoted by AR to the power of n minus 1. So that will be my nth or last term, and we have to be very familiar with that because that formula there will help us to determine the general term, which is used to help us to find the value for the particular position or rank. Sorry? How many terms? It can be any number of terms. Any number of terms. All right? So it can be any number of terms. So if they want you to, if this is the first, second term, between my third and my n terms, I can have X number of terms. It doesn't matter how many. Okay? What we want to do is to be able to use this important formula I'm going to write. T is equal to AR to the power of n minus 1 to find the value of a particular term. So for example, if they wanted me to find the value of the fifth term, I can use this formula here to help me to find the value of the fifth term. Provided I know A, which is my first, provided I know R, which is my common ratio, and of course if it's a fifth term, I'm going to replace n with 5. So this becomes 5 minus 1. So we can have any number of terms, and they can ask you to find the value of that particular term. You can identify a term, say the ninth term, and you have to find the value of that ninth term. Okay? So this here is an important formula which is used to help us to find the value of a given term. So now just quickly show an example just to highlight it. Likewise, if we have here for the GP to find the sum to n terms, we have to also know how to find the sum to n terms, sum to x number of terms. So for us to do so, we are going to use an important formula for the GP, which is A into 1 minus R to the power of n all over 1 minus R. And this formula is used for the GP provided the common ratio is less than 1. Once this common ratio R is less than 1, then we can use this formula to find the sum to that given term. So if I have as well, I can use another formula to find the sum to n terms, and that is A into R to the power of n minus 1 over R minus 1. And this formula is used provided the common ratio is greater than 1. If the common ratio is larger than 1, then we'll use that second formula to find the sum to n terms. And likewise for the GP, there is one more very important sum known as the sum to infinity. And they like to ask questions relating to the sum to infinity. So the sum to infinity, that's your infinity symbol, is formed by using the formula A over 1 minus R. And normally the sum to infinity is used when the common ratio is less than 1. So for the GP, you have to know the general formula. That's to find the value of a particular term. So you call it the general formula or general term. We have these two very important formulae here, which is used to find the sum to n terms of your GP, and the last one is used to find the sum to infinity. All right? When it comes to the arithmetic progression, this is your general term. The formula used to find the value of a given term, and this here is used to find the sum to n terms. Okay? Of your AP. So this is your AP, this is your GP. I know you want to make sure we know these important formulae before we enter the exam tomorrow. Okay? So what I'm going to do is, look at a question. We're going to look at 2 questions from the past papers, 2 common type questions you see in the examination. And, let's see how we can answer those questions as quickly as possible, all right? So I'm going to erase the board and put on the PowerPoint of question, right? So we want to make sure that we're clear on AP GPs, because you know this is going to come in your exam tomorrow. So let's make sure that we understand how to use the formulae, and of course apply what we know to get the answer right tomorrow, right, when it comes. So let's look at this question. Right, so I'm taking this question, it's from June 2012, and it's normally a question where we have some pieces of information, key pieces of information given to assist us in answering the question. It says here, a customer repays a loan monthly by increasing the payment each month by X dollars. So every month you keep adding X dollars, keep increasing by X dollars. And that should give a hint as to what kind of progression it is. All right, remember with APs, what you do, you move from one term to the next by adding that common difference. Whereas the GP, you move from one term to the next by multiplying that common ratio, yeah? So if the customer repaid $50 in the 5th month and $70 in the 9th month, calculate the total amount of money repaid at the end of the 24th month. So we have this customer, they're repaying a loan, and of course, to repay that loan, you're going to obviously make your first payment, not so, towards that loan, which we denote by A. So that's your first term. So it's always a first term. Of course, in the 5th month, right, how much was repaid? $50. In the 7th month, or in the 9th month, how much was repaid? $70. And they want us to calculate the total amount of money repaid at the end of the 24th month. So at the end of the 24th month, what is the total amount of money repaid? From when you started to the 24th month, what's the total amount of money? And total amount of money being repaid should indicate something automatically, that should trigger something in your mind. So total will lead to what? Sum, all right? So if we know we have to, in this question, find the sum to 24 terms, because we want the sum to 24 terms up to the 24th month, right? We know what should register in our mind is the formula for the sum to n terms of an AP. And this is an arithmetic progression, because the customer repays the loan monthly, increasing by X dollars each month. So every month, your loan payment increases by what? X dollars, the same amount of money every month. It keeps increasing, you keep adding, right? It keeps increasing by X dollars every month. So it's an AP. So what we should automatically do, knowing it's an AP, and we want to find the sum to 24 terms, we should write our formula. S is equal to n over 2 into 2a plus n minus 1d. We're going to use this formula to help us to find the sum to 24 terms. Yeah? We know n will be, because it's a sum to 24 terms, n obviously will be 24. We need to also find a, and we need to find d. A being your first term, d being the common difference, because that is important for us to find the sum to 24 terms. So the next question is, how are we going to find a and d? We have n, we know we're going to replace n. This n here, we're going to replace it with 24. Yeah, the n inside of the bracket we're going to replace with 24. But what are we going to replace a and d with is an important part of the question. So to replace a and d, this is where we have to create 2 equations based on the information given, and we have to solve those 2 equations simultaneously to find a and d. Anytime in math or AddMath, as I was saying last night, we have to find for two unknown quantities, you have to create a pair of equations and you solve them simultaneously. So in this case, to find A and D, what are we going to use in the question? They gave us some key information. They told us in the 5th month, $50 was repaid, and in the 9th month, $70 was repaid. So from these two pieces of information, we can create two equations. And look at it here. To create those two equations, we're using another formula that was just written on the board. That is T is equal to A plus N minus 1D. This is the formula we're going to use to create two equations. All right? So we know T here represents the value of the given term. So in the 5th month, $50 was repaid, so T will represent your $50. Remember, T represents the value of the given term. Yeah? So for my 5th term or my 5th payment, it's $50. So I replace T with 50. A I don't know, that's what I have to find. So A stays, plus N will be the position. This is my 5th payment, yeah? So therefore I'm going to replace N with 5, which is the position. So I replace N with 5, minus 1, and D, of course, is the common difference. Remember, every month, you keep adding what? X dollars every month. Yeah, it keeps increasing by X dollars every month. So you know that that represents a common difference, which I'm going to obviously replace with X. Yeah? So let us now create an equation so we can find both A and X when we have to solve them simultaneously. This is one of the equations we're going to create. So this becomes 50 is equal to A plus 5 minus 1 is 4, X. So this is one equation we have created. If you wanted to leave D, no problem, yeah? Because that's what we have to find. X and D are the same thing. If you wanted to leave D instead of writing X, no problem. So this is one equation you have created to help you to find A and X or A and D, right? Remember, X and D are the same. So one equation created. Let's create another equation. They gave us another piece of information. In the 9th month, $70 was repaid. So let's create another equation based on our general term. T, of course, will be the amount of money paid in that 9th month, which is $70, is equal to A is your first term, which you don't know. That's what you have to find. N is the position, so the 9th, yeah? So in the 9th month, of course, $70 was repaid, so replace N with 9 minus 1. And D, of course, will be your common difference, which you can write that D as D or X, any one of the two. So what I have here is my second equation. This is my first, and I have now my second equation. Let me simplify. This becomes 70. A plus 9 minus 1 is 8x, and this here will be my second equation created. So I've created two equations based on the information given that can help me to find A and D, right? Remember, we can replace D with X if you want, because they use X to represent the common difference in the question. And once we get A and D, knowing that we want to find the sum to 24 months, then we can easily obtain that value. So let's go get A and X by solving a pair of equations simultaneously. So to solve that simultaneously, what we're going to do? We are going to, and let me write both equations here. This is, if you want, many students like to work with the unknowns on the left and put in numbers on the right. So if you want to switch it around, no problem. If you want to write it as A plus 4x is equal to 50, and A plus 8x is equal to 70, no problem, yeah? Of course, we can eliminate A first by subtracting both equations. So I put my subtraction sign in between. When I subtract those two equations, what's going to happen? A minus A is 0. I'm going to get 4x, subtract 8x. So 4x subtract 8x is equal to 50 subtract 70. 4x subtract 8x will give me negative 4x. 50 subtract 20 will give me what? Negative 20. And therefore, to get x by itself, I'm going to divide both sides by -4. And I'm going to divide -20 by -4. So x, the common difference, that amount of money that increases every month, that allows our payments to increase every month consistently, that consistent amount of money will be what? $5. All right? So every month we increase by what? $5 as we pay towards the loan. All right? So a customer repays a loan monthly by increasing the payment each month by X dollars. So each month you keep increasing by that consistent amount, which is $5. So you have found X, otherwise known as the common difference. So after we have found X, this is a simultaneous equation, a pair of equations we're solving simultaneously. Let us go find A, the first term, so we'll know what is the first payment made towards this loan. So the first payment made towards this loan will be what? I'm going to substitute X equal to 5 into any one of the original equations, 1 or 2, you pick one. Substitute X equal to 5 into, let me put it into the first equation, into equation 1. All right, so remember this is equation 1, this is equation 2. So equation 1, I have A plus 4x is equal to 50. I'm going to replace x with 5, so it becomes A plus 4 times 5 is equal to 50. A plus 20 is equal to 50, and therefore A is equal to 50 minus 20. A will be $30. So the first payment towards this loan will be $30. All right? So what we have done here so far, we have gotten 2 pieces of information that can help us to find the sum to what? 24 months. How much money was paid at the end of the 24th month? Yeah? So what is the total amount of money? And we're using that formula to help us to do so. So with this question again, pieces of information was given. The 5th month we repaid $50. The 9th month we replaced $70. We use a general formula, general term, to create a pair of equations which we solve simultaneously to find the first term and the common difference. So let's get our sum now. So our sum will be S is equal to n over 2 into 2a plus n minus 1d. Of course, d we can use x if you want instead of d, no problem. So this becomes S is equal to, we know n, we're going to replace it with 24 because we want the sum to 24 terms up to the end of the what? 24th month, which is the sum to 24 terms. So therefore, this will be 24 over 2 into 2 times A, of course, which we got to be $30, plus n minus 1, that's 24 minus 1, times the common difference, which we worked out to be $5. So let's simplify that. We're going to get what? S is equal to 2 into 24 is 12. 2 by 30 is 60. This is 24 minus 1 is 23, and that's 23. Be careful here. That's 23 multiplied by 5. So that n minus 1d is n minus 1, which is of course 24 minus 1, which is 23, times 5. So you're multiplying that by 5, all right? So we're going to get S is equal to 12 into 60 plus 23 by 5 will give us 5 3s are 15, 115. And therefore, S is equal to 12 times 60 plus 115 is 175. And 175 by 12 175 by 12. When we work out that, we'll know what's the total amount of money we paid up to that 24th month, right? 12 by 175. Right, so we should have gotten $2,100 will be the total amount of money we paid at the end of the 24th month, right? So at the end of this 24th month, what is the total amount of money we paid? So far, $2,100, all right? So this here is an important question treating with APs, and let's make sure we know it. They like to bring questions like this. We have to create a pair of equations and solve them simultaneously to achieve what is required. Let's look at another. So I hope we're all clear. If we're clear, let me see a thumbs up, show a thumb. Are we clear? And let's look at an example similar to this where GPs now is applicable. Yeah, geometric progression. So show of thumbs. Are we clear with what was done here? So let's move on to a GP now. So GP. So let me find an example here where we have a geometric progression. So same concept. Right, okay, let's look at this one. So I'm going to erase this information. And then we're going to move on next to equation of a circle. All right, so let's look at this one. If it says here, in this question, an accountant is offered a 5-year contract with an annual increase. So 5-year contract, and every year, of course, there's an increase in his, I guess, salary, right? The accountant earns a salary of $53,982.80 and $60,598.89 in the 3rd and 5th years, respectively. So in the 3rd year, that's the amount he earned. And in the 5th year, that's the amount he earned, $60,598.89. If the increase follows look at it, a geometric series. So they highlight the kind of series, geometric series. Calculate the amount paid in the 1st year. So how much money this accountant received in his 1st year of, I guess, this job. This new job he attained, right? So the trick with this again, it's a GP. Once it's series, you know you'll have your first term, right? In the 3rd year, he earned. So this is our first. Let me put the first in red. 3rd. In the 3rd year, he would have received $53,982.80. In the 5th year, he attained $60,598.89. Okay? So the question is, the amount of money paid in the 1st year. So what is A? How much money was paid in the 1st year? Okay, how much money this accountant received for his 1st year on this job? Okay, so the question says it follows a geometric series. So once it follows a geometric series, you must understand that there must be a first term, and because it's a geometric series, there must also be a common ratio. That common ratio is the constant that allows us to move from one term to the next, right? It's consistent throughout. You saw when we dealt with the question before, that common difference for an AP the common difference was 5. So every year it keeps increasing by $5. So what is this constant that, of course, allows us to move from 1st to 2nd to 3rd to 4th and so on? So That constant is known as the common ratio, which is R. That we don't know. But it is needed to help us to find the amount paid for the first year. And I think there's a second part of this question. The total salary earned at the end of the contract. So at the end of this 5 years, how much money this person would have achieved, this accountant would have been paid at the end of the 5-year contract. All right? So let's get the amount paid in the first year. Again, we know we have to get A and we have to get R. Two very important variables, two. So if you have to find two unknowns, what will automatically come to your mind is a pair of equations, which you're going to solve simultaneously. All right? So with GPs, the approach is going to be a bit different. So let's see what information we have that can allow us to create a pair of equations. In the 3rd year, he would have been paid this amount of money. In the 5th year, he would have been paid this amount of money. So we're using this information to create a pair of equations. And remember, if it's GP, the general term, remember, the general term for GP is T AR to the power of n minus 1. Remember that. Good? So in the 3rd year, let's write it down here. He got $53,982.80. In the 5th year, he got $60,598.89. So in the 3rd year, using this general, remember T represents the amount of money. Yeah? The 3rd year, of course, A we don't know, so A stays as is. So I'm going to rewrite this first equation as A. R we don't know, R stays as is. And we're going to replace with what? 3. That's my 3rd, right? That's a position when it comes to using the general term. N in that formula represents the position of the term. So this will be my 3rd minus 1 is equal to $53,982.80. This can also be rewritten as what? AR squared. So my 3rd term is represented as AR squared is equal to $53,982.80. So that's one equation created there. We have one equation. Let's get the second equation. In the 5th year, he's paid $60,598.89. So the 5th will be what? T represents the amount of money. So this is the amount of money, that's a T. So that is, let me write it here. The $60,598.89. A you don't know. R you don't know. N of course will be the position, 5th month or 5th year, right? So this is 5 minus 1. This will simplify to become AR to the power of 4 is equal to $60,598.89. So we're going to call this equation equation 2. So you have 2 equations created based on the information given. 2 equations created. So what you want to do now is solve the pair of equations so you can find A and you can find R, the first term and the common ratio, which is essential to help you to determine part 2, the total salary earned at the end of the contract. So we are going to get the amount paid in the first year, which is the first term. We're going to work it out in the process, and we're going to use, of course, A and R to get the total amount of money paid at the end of the contract. So how are we going to get this A and R? Using these 2 formulae here, we are going to, which is very important when it comes to GPs, how you treat with GPs when 2 equations are to be solved simultaneously. What you're going to do is this. You're going to divide equation 2 by equation 1. Yeah? You're going to divide the higher position by the lower position. So you put the higher position, which is the 5th, right? And of course, that will be on top in your numerator, and you're going to put the lower position below in the denominator. So this will be written as what? So I'm going to put, this is my fifth term, so I'm going to write AR to the power of 4. That is equation 2 over my third term, which is AR squared, is equal to, take the amount for my fifth term of fifth year, which is $60,598.89, and I'm going to divide it by the amount in my third year, $53,982.80. So you always take the higher position and divide the lower into the higher. So the higher will be on top, the lower will be below. So this is equation 2 divided by equation 1. So when it comes to GPs, this is how you treat with it. You divide the two equations. And let us now simplify. Look at what's going to happen. My two A's will divide into each other to give 1. R to the power of 4 divided by R to the power of 2 gives me R squared. Let me divide those two numbers there. That is $60,598.89. I'm going to divide that by $53,982.80. Right. So I'm going to get 1.12255. Now you don't have to take all the digits after the point. If you want, no problem. 9223. And therefore, to get R now, which is the common ratio, I'm going to find the square root of that number. So the square root of 1.122559223. So when I find the square root of that, I'm going to get, so this will be 0.122559223. We're going to get 1.05. You can approximate that probably, if you want to put it to 2 decimal places, no problem. So if I approximate that to 2 decimal places, I'm going to get 1.06. All right? So this here is my common ratio. All right? So every year, we're going to take this amount and multiply it by the previous so we can get the present. Okay? Because with the common ratio, you multiply by the previous to get the present. Yeah? So this is our common ratio. This is what we got. But remember, it's not only about finding the common ratio. We need to find the first term as well. And this is what we want to find in part 1, the amount paid in the first year. So to get the amount paid in the first year, what we're going to do, just from your knowledge of simultaneous, when you get the first variable, you're going to substitute the first variable into any of the two equations to get the second. So let's take the first variable and let's substitute it into equation 1, easy of the two equations. So I'm going to substitute R is equal to 1.06 into equation 1. And when I put that into equation 1 is what? AR squared is equal to $53,982.80. So let me replace R with that value. I'm going to get what? A times 1.06 squared is equal to $53,982.80. And therefore, what am I going to do? Let me square 1.06. So that is 1.06 by 1.06, which will give me 1.1236A, and that is equal to $53,982.80. So therefore, to get the first term, which is the amount paid in the first year, let's see how much money this accountant got in his first year on the job. This will be A is equal to $53,982.50 divided by that 1.1236. Let's divide those two numbers and let's see what we're going to get for the how much you got for this first year. 982.50 divided by 1.1236. All right, you got how much you got? Yeah, you got a nice amount of money. Of course, it can't beat what he got in his third and fifth year, right? But he got A is equal to $48,044.23. So that's how much he got in his first year. So for the first part of this question, when they ask us to determine your amount paid in the first year, and you see this question carried 4 marks, so 4 marks is plenty in an AddMath exam, right? It required us to read the question, get two very important equations based on the information. You divide one into the other, right? The lower term into the higher. Finding the common ratio, substituting the common ratio into one of the equations, and finding the first term, all right, which is the amount paid in the first year. All right? So this is part one of this question. We clear on that, everybody? Yeah, we clear on that? We see a short thumb? So we're going to move on now to the second part of the question where, yeah? Sorry? Oh, really? Right. So let's look at now the second part of this question. Right, the second part of the question asks us to determine the total salary earned at the end of the contract. So the total salary, total, when you see total in a APGP's question, it means the sum. Okay? What is the total amount of money? So let's get that. So part two of this question, what's the total amount of money? So the total salary earned, so that's for the 5-year period, what's the total amount of money earned? Again, it's a geometric progression, so know your formula. S is equal to, when you create your formula or your formula based on the common ratio. You see, common ratio there is greater than 1. Remember, there are two formulae I gave you to find the sum. So because the common ratio is greater than 1, which one are you going to use? You're going to use A into R to the n minus 1 over R minus 1. You use this one when the common ratio is greater than 1. If you see R is more than 1, so you know that's the one you're going to use when R is greater than 1. Because you got your common ratio as 1.06, and that's more than 1. So let's substitute now into our formula. S is your sum. A is the amount we calculated there, which is the $48,044.23. R is the common ratio, which we got as 1.06. And of course, we want the sum to, at the end of the contract, which is 5 years, so you want the sum to 5 terms, minus 1 over R, which is 1.06 minus 1. So let's work on that and see what we're going to get. This becomes S is equal to 48044.23. Let's work out 1.06 raised to the power 5. We're going to get here, I'm going to put 1.3382. Let's take about 4 places after the point. Subtract 1. All over 1.06 subtract 1 will give me 0.06. So we're going to get what? S is equal to 1.3382 subtract 1 is the same as 0.3382. And let me multiply 0.3382 by 48044.23. So I'm going to get 1624.8.558, and let me divide that by 0.06. So let me divide that now by 0.06. Right, so in all for this 5-year contract, this accountant would have been paid by this company $270,809.31. So I'll approximate it in every cent. All right? So this is how much this accountant is paid at the end of the 5-year period. So understanding here APs and GPs, just be aware of this type of question. It's very possible you can see something like this tomorrow where you have to create 2 equations to solve for 2 unknowns, which will then be used to help you define what is required. Okay? So, can I see by show of thumbs? We clear on this part too? Show of thumbs? Yeah? So let's move on now to, we're going to move on now to equation of a circle, right? So equation of a circle. So we're moving on to section 2 now. So section 2, so you know section 2, make sure you know in terms of the order of the questions, right? Because you normally can follow the order. You know the equation of a circle, then like a sector question, and then they'll bring a vector question, and then they'll bring up trigs, right? So you want to make sure we understand questions relating to those, right? All right, so let's look at equation of a circle, right? And when you deal with the equation of a circle, now the first thing you need to understand with a circle, equation of a circle, 2 important things you need to consider. There's a center and there is a radius. So that's your center and then you have a radius. Well, I'm trying to do as much as possible within a 3-hour period. So we started at about 8:30. Yeah, so about 11:30 around there, right? Trying to end by that time, okay? So we have here our center, whose coordinates, you can call them H and K, right? And of course you have your radius. Now, note with the equation of a circle, there are 2 ways in which you can represent the formula. There is a standard form and there is a general form. Now, sometimes you're going to see where the center, and normally the formula used in the formula sheet in the examination will normally relate to a center which is written as negative H, negative K. Now, it doesn't matter which one you use, right? If you're using this, where the coordinates are positive H, positive K, then of course, there's a particular representation for both the standard form and general form. If you're using the center as negative H, negative K, there's a particular representation which you normally see in the formula sheet for the standard form and the general form. It doesn't matter how you use it, you get the same answer, all right? So, if we're going with positive H, positive K, the standard form is derived from Pythagoras. You write it as x minus h, and sometimes they use f and g as the centers, f minus h in brackets squared plus y minus k in brackets squared is equal to r squared. So that's the standard form, okay? The general form is when you take this and expand it out. When you expand it, you're going to get what you call the general form. And the general form will be x squared plus y squared minus 2hx minus 2ky plus c is equal to 0. And you must also include as part of this formula, c is equal to h squared plus k squared minus r squared. So you must include that as part of your formula, all right? So very important. This whole thing is one formula. Now, if you decide to go with the center as negative h, negative k, when you look in the formula sheet, you're going to see this formula for the standard form and this formula for the general form. And again, it doesn't matter which one you use, you're going to get the same answer. So this will be for your standard form. If you decide to use negative h, negative k, it's going to be x minus, instead of positive h, I put negative h in bracket squared, plus y minus negative k in bracket squared is equal to r squared. And this is what you see in the formula sheet. It becomes x plus h in bracket squared plus y plus k in bracket squared is equal to r squared. Alright? So that's what you see in the formula sheet. So you normally use this if you decide to go the center as negative h and negative k. Alright? For the general form, the same applies, right? Again, if we're going with negative h, negative k, this is the formula you see in the formula sheet. It's going to be x squared plus y squared minus 2. You're going to replace the h, of course, with negative h. X minus 2, k with negative k, y plus c is equal to 0. And this will simplify to become x squared plus y squared plus 2hx plus 2ky plus c is equal to 0. Alright, so this is the general form if you decide to use your center as negative h, negative k. So you have this representation. Alright, so that's a standard form and general form for the equation of a circle. This is the standard form. And keep it in mind as well, you must include with your equation c. So where c is the same representation there, is equal to h squared plus k squared minus r squared. That is a part of that, this very important form. Alright, so they work hand in hand. So the same here, these two work hand in hand. So this c equal to h squared plus k squared minus r squared works hand in hand with that formula. Alright? So you want to make sure you know your formulae for the equation of a circle. So let's look at one or two questions, just to highlight it. Okay, so let's look at this here. Alright, Tommy Rayson. The information. And it says here, we have this equation of a circle. It's in the general form, right? You have it in the expanded form. And they want us to determine the coordinates of its center and the length of the radius of the circle. Okay? Yeah? So you want to find the coordinates of the center and the length of the radius. So, if you want to find the coordinates of the center, remember, of course, if you decide to go, and I'll show you all both ways so you can see. If you decide to go, remember your center will have two coordinates, which let's call them h and k, for example. Sometimes you see f and g. R is your radius, okay? And if we want to find the coordinates of the center, and we have this formula here, x squared plus y squared plus 4x minus 8y plus 10 is equal to 0. Good? If you decide to use your center as positive h, positive k, good? Then, to help you to get the coordinates of the center, you're going to use your general form, which I stated previously, to help you. Now, you're going to use what I like to use and what I encourage students to use. I mean, it doesn't matter, there are different ways. I like to encourage students to use the process of equating coefficients. So, if I'm going with positive h, positive k, my general form I'm going to use will be x squared plus y squared minus 2hx minus 2ky plus c is equal to 0. That is what I'm using, all right? And I'll show you all if you went with negative h, negative k, where you get the same answer, all right? So I'm going to use a process of equating coefficients. So equating coefficients of x and y. So I'm equating coefficients of x and y. What that means, I look at x here. So this is the general form. So you'll make sure you focus on your general form, and I'm going to equate it with the equation given in the question. So x in the general form, the coefficient is what exists in front of x is negative 2h. X in the equation given in the question, the coefficient of x is positive 4. So what I'm going to do is put these two equal to each other. That negative 2h and positive 4. So I'm going to put negative 2h is equal to 4, and therefore h is equal to 4 divided by negative 2. H is equal to negative 2. And that will be the x coordinate of my center, negative 2. Yeah? What about the y coordinate of your center, which we denote by k? Sometimes you see f and g, right? So do the same thing. I'm going to equate coefficients. The coefficient of y in my general formula is negative 2k, and the coefficient of y in the equation given in the question, the formula given in the question, is negative 8. So I'm going to put these two together. I'm going to equate them, put them equal to each other. So I'm going to put negative 2k is equal to negative 8, and then I'm going to divide both sides by negative 2. So k is equal to 4. So the coordinates of your center is negative 2, 4. All right? So that's the coordinates of the center. But remember, you can also do it like this too. Huh? So this is 4. You can also do it like this too. If you wanted to go with, because I mean, some students know it as the center being negative h, negative k, right? You can do that as well too. So again, you'll do the same equating process, but remember, if you decide to go to center as negative h, negative k, you're going to take the formula given, and if you decide to go to center as negative h, negative k, the formula you're going to use, the general form you're going to use to help with the equating process will be x squared plus y squared plus 2hx plus 2ky plus c is equal to 0. That's the formula you're going to use. Yeah? And look at what's going to happen. Of course, I'm going to equate what exists in front of x in the general form with what exists in front of x in the equation given in the question. So I'm going to get 2h. Let me write here equating coefficients of x and y. So when I equate coefficients of x and y, what's going to happen? I'm going to put 2h is equal to 4, yeah? H is equal to what? 4 over 2, h is equal to 2, but remember, you're using your center as negative h. So negative h will be equal to negative 2. So I've got the same negative 2 as the x coordinate of my center. Similarly, you can equate coefficients of y. So you're going to put what? This negative 8 equal to that what? That 2k. So I'm going to put 2k is equal to negative 8. K is equal to negative 8 over 2. K is negative 4, but you're using your y coordinate of the center as what? Negative k. So it's going to be negative k is equal to 4. I'll just put my negative sign in front of negative 4, so it becomes positive 4. So either way, you're going to get the coordinates of the center. So you found this part here, the coordinates of the center as negative 2, 4. All right, so that will be the answer for part 1. But then we also have in that part of the question, and the length of the radius. What's the length of the radius? So to find the length of the radius is going to be pretty straightforward. Remember, with this general form, you have an attachment. That attachment is what? C is equal to h squared plus k squared minus r squared. You have that attachment. So make sure you remember that attachment, which is linked to this general form, right? And how are you going to use the attachment to get the radius, to get that r there? You know C is what? C will be the constant in the equation given, which is 10. So you see this 10 here? That 10 represents your C. So you're going to put 10 is equal to, we know what is H. H is what? H, of course, is the x coordinate of your center. We have as negative 2. Plus, k, of course, will be the y coordinate of your center, which is 4. Subtract r squared. So what we're going to get? This becomes 10 is equal to negative 2 squared, which is what? Positive 4, plus 4 squared, which is 16, minus r squared. You're going to get 10 is equal to 20 minus r squared. Unless I'll put negative r squared on the left, it comes across as positive r squared is equal to 20 minus 10. And therefore r is equal to, r squared is equal to 10, r is equal to the square root of 10 units. So the radius of your circle is the square root of 10, and don't forget to write the word units at the end, okay? So this here is a question involving the equation of a circle where they ask you to find the coordinates of the center and the length of the radius. So you just have to make sure you know your two very important formulae, the formula for the equation in the standard form and the general form. Just note, if you decide to use the center as positive h, positive k, just remember how the equation will be stated. If you decide to use your center as negative h, negative k, just remember how the equation is stated, okay? And what you see in the formula sheet is this, which is normally when the center is negative h, negative k. But it doesn't matter which one you use, you get the same answer. Okay, let's look at part 2 of this question. And then I'm going to move on, because I have to move on quickly because of time. We're going to move on next to a sector question. All right, let's look at the second part. Determine the equation of the tangent to the circle at the point negative 5, 5. So we would have found, all right, so I hope we're all clear, thumbs up, right? If we're clear on what I explained here in terms of the equation of the circle to get my coordinates of my center and my radius. Thumbs up, thumbs up. Yeah? Right. So we have here, so make sure we understand that, because for sure you're going to see this tomorrow. You're going to see it tomorrow. Even though ifs, no buts, you're going to see it. Right? So, next very important part of this question is, which you love to bring. You love to bring this part, right? Determine the equation of the tangent to the circle at the point P negative 5, 5. So you want the equation of the tangent to the circle. A tangent is a line drawn to meet the circle at a given point. The circumference of the circle at a given point, that's a tangent. It's a line drawn to meet the circumference of the circle at a given point, called a point of tangency. Now, this is the radius, this is a tangent, and there is a very important topic which you should all know. Everybody prepared for that topic in mathematics, circle theorems. You're supposed to know when a radius and a tangent meet at that point of tangency, they meet at right angles to each other. So if I have to find the equation of that tangent, this is point P whose coordinates are negative 5, 5. This is my center whose coordinates are negative 2, 4. So if I have to find the equation of my tangent, this is a line. So if you have to find the equation of a tangent, that line, you know you're going to use what? Y is equal to mx plus c. That should automatically come to your mind. You know m is your what? Gradient. C is your what? Y-intercept. So you're going to get your gradient. You don't know the gradient of this line presently, this tangent, but you can find it. Again, and this is where coordinate geometry will come into play. We have 2 points on the radius, so you can use those 2 points to get the gradient of the radius, otherwise known as your normal. The normal is perpendicular, it meets the tangent at right angles. So the radius is also referred to as a normal. Keep that in mind, right? So let's get the gradient of the radius. Slash normal, right? Of course, we know the formula for the gradient of a line. Let me call center C, negative 2, 4, point P, negative 5, 5. My formula for the gradient of a line, please make sure you know this. Everybody should know. It's M is equal to Y subscript 2 minus Y subscript 1 over X subscript 2 minus X subscript 1. Right? We label this as X1, Y1, X2, Y2. Let's substitute into our formula for the gradient. M is equal to Y2, which is 5. Subtract Y1, which is 4. Over X2, which is negative 5. Subtract X1, which is negative 2. But you make sure you put negative 2 in brackets. So this becomes what? This becomes M is equal to 1 all over negative 5 plus 2, which is negative 3. So the gradient of the radius, you see that radius? The gradient of that radius, M, is negative 1/3. But you don't want the gradient of the radius, you want the gradient of the tangent to find the equation of the tangent. And you know when two lines from coordinate geometry meet at right angles to each other, we can use what we call the negative reciprocal to get the gradient of the tangent. So I'm going to put negative 1, let me write it in red, over the gradient of the radius. And negative 1 divided by negative 1/3 will give me positive 3. And you know from coordinate geometry, when two lines are perpendicular and you multiply both gradients, you are supposed to get negative 1. So it will prove that this gradient of the tangent is right. So you know that the gradient of the tangent, M, is 3. But you need to also find C, which is the y-intercept. And we all should know how to find C. Once there is a point on the tangent, where there is a point P, whose coordinates are 5, negative 5, we're going to use the coordinates of that point along with our gradient M equal to 3 to find the C. And look how straightforward. This is your X coordinate, this is your Y coordinate. You're going to replace Y in the equation with 5. You're going to replace M with 3. You're going to replace X with negative 5. You put that in brackets, plus C. So we're going to get here 5 is equal to 3 by negative 5 is negative 15 plus C. And therefore we can make C the subject by adding 15 to both sides. C is equal to 20. So the equation of this tangent is Y is equal to 3x plus 20. And that's the equation of the tangent. So please make sure you know this. Make sure you know your equation of a circle. Make sure you know about the tangent to the circle. Also make sure you know sometimes it'll bring a question where you have a line, cutting the circle at 2 points. And if you have to find the coordinates of those 2 points, you have to solve simultaneously the equation of the line and that of the circle. Okay? So you'll have a non-linear, which is your circle, the equation of the circle, and linear, which is your line. Sometimes, they may give you both equations, that of the circle and that of the line, and if you solve them simultaneously, and the circle and tangent, the tangent meets the circle at 1 point, all right, then this line is a tangent. So when you solve the equation of the line and that of the circle simultaneously, if you get the coordinates of 1 point, it means that this line will not cut the circle at 2 points. It's going to meet it at 1 point, and therefore this line is known as a tangent. Okay? So this is something you need to also be conscious of. All right, so let's move on now to sectors. So I hope you're all clear on that. If you're clear on me finding the equation of the tangent, thumbs up, right? Thumbs up. Right, so let's move on to sectors. Now, we know that a sector, when you talk about sectors, a sector is a part of, a piece of, a fraction of, your circle. Like if you go Mario's, you buy a pizza, the pizza is circular, and you pull out a slice, that slice you pull out is a sector, right? So a sector, so looking at circle, what you call circle measure, all right? Now, with circle measure, what we need to know, of course, you will have a sector. That's my sector, and a sector will have a sector angle. Of course, this is the center of my circle, a line running from the center to my circumference. This is my length of arc, which is a fraction of the circumference as well. This line from the center to my circumference is the radius. This is also another radius, and I have 2 radii. This is my length of arc. So from here to here, it is known as your length of arc. And we sometimes know the length of arc by S. Okay? Now, most times with questions involving sectors for AddMath, the sector angle is in radians. Okay? So, some students, often try to convert the sector angle from radians to degrees and try to work in degrees. But I will always advise if the sector angle is in radians, stick with radians and the formulae linked to that angle in radians. So, the 2 things you have to know, which is very important, is to find the area of a sector. And the area of a sector, so if I have to find the area of the sector, if the angle is in radians, I'm going to use a half r squared theta. So you should know that formula. R is the radius, theta is the sector angle. Okay? And sometimes, they may give you the area, they may give you the radius, and you just have to do some transposing to get the angle theta. You also need to know there's a length of arc S. So S, your length of arc. S, of course, the area is A. The length of arc S is found by using the formula r theta. So don't forget that. That's provided the angle is in radians, which it will be for AddMath. Good? But something else you need to be conscious of. Sometimes they may give you, and we're going to look at a quick question. I think this came in 2021, somewhere around there. They will give you something like this, where this is a chord drawn from A to B. And this chord, of course, will divide this sector into 2 regions. This region here, which is a triangle, and this little piece here, which is shaded, this is known as your segment, minor segment. Okay? So this here is a chord. So to find the shaded region, you will have to be able to, very important, find the area of the triangle. You have to also find the area of the sector. If you take the triangle away from the sector, pull this triangle away from the sector, what you're left with is the shaded region. Okay? But what you need to know is how to find the area of the triangle. So we often, we'll use base by height over 2. That is used provided you have a perpendicular height and base. But, most times with the sector questions, you'll see where you have two known sides and an included angle. Once you see that taking place, then to find the area of the triangle, and get familiar with this formula, it's going to be a half times this radius by sine the angle theta. Okay? And r by r is known as r squared. So that is a half r squared sine theta. So make sure you know that formula to find the area of a triangle. Alright? So let's make sure we look at a quick question to highlight that. And then we're going to move on to vectors. Alright? So let me pull this question here. Right. So this is from June 2022. Good? So let's look at this here. So if we have this question, the diagram below not drawn to scale shows a chord AB, which subtend means to create that angle at the center of 0.5 radians. And you see that as 0.5 radians. At the center of the circle of a radius 10 centimeters. You see the radius 10 centimeters, right? Given that the area of the triangle, and you see, look at the formula I give here. Area of this triangle, AOB, is a half r squared sine theta. Calculate the area of the shaded region. The shaded region, which is otherwise known as your minor segment. So to get the area of that shaded region, you're going to take the area of the triangle away from the area of the sector. So just focusing on this little piece here, the sector. So you're taking the area of the triangle away from the area of the sector to get the area of the shaded region. Okay? So let's proceed. So to get the area of the shaded region, that is equal to what? Area of this, and the area of the sector will be first, because that's the bigger area. So always look to see which one is bigger. The bigger area will be written first. Area of sector. Subtract the smaller region, which is the area of the triangle. Good? Of course, you know what's the area of your sector formula? A half r squared theta. So the area of sector, and I'll just write them separately, is a half r squared theta, which is a half multiplied by your radius is 10 centimeters, so that's 10 by 10, by the sector angle, which is 0.5. Right? And now let me work that out. This will be 2 into 2, 1, 2 into 10, 5. That's 50 by 0.5. And of course, that will give me what? 50 by half, that's 25, right? So I'm going to get 25 centimeters squared, or squared centimeters. Will be the area of the sector. But I also need to find the area of the triangle. So area of triangle. So how am I going to find the area of the triangle? Again, look at this triangle. This here, this radius is also 10 centimeters. So what you have here are two known sides and an included angle. Two sides meet to form an angle which is known. Two known sides, they meet to form an angle which is also known. So what you're going to do is use this important formula here, all right, which is A is a half by R by sine theta. So make sure you know that formula for tomorrow. This will be A is a half times, the radius is 10, so that's going to be 10 by 10 by sine theta, which is 0.5. But you have to be very careful. Be very careful when you're using that formula. Once the angle is in radians, and be very conscious of this. Once the angle is in radians, you have to make sure you change your calculator from degrees to radians to work out sine of 0.5. Make sure that is done. Yeah? So make sure your calculator is in radians. And once you do that, you can work out sine now of 0.5 multiplied by, of course, 2 into 2, 1. 2 into 10 is 5. So it's going to be 50 by sine of 0.5, making sure sine of 0.5, that is in radians. Put your calculator in radians, right? So once it's sine of an angle, and if the angle is in radians, you have to make sure you convert the calculator. So we're going to get what? Sine of 0.5 will give me 0.4794, go down the road, right? And I'm going to multiply that by 50, which will give me 23.97. If you want to approximate it to the nearest whole, no problem. You can put 24 cm squared. And I'll approximate it to the nearest whole number to give me 24 cm squared. So having found the area of the triangle and the area of the sector, I have both pieces of information I need. Let me get the area of the shaded region. So the area of the shaded region now will be my 25 centimeters subtract 24 centimeters, which will give me what? That will give me 1 cm squared. As the area of the shaded region. Okay? So you have here two very important pieces of information, area of the sector, area of triangle, and you subtract them to get the area of the shaded region. Okay? So please make sure you know these important formulae for the exam tomorrow. Alright? And I hope we're all clear on what was done here. If we're clear, let me see a thumbs up, thumbs up. Yeah? So let's move on now to vectors. So moving on to vectors, right? So vectors now. So looking at vectors. So right, so with your vectors, you know, you want to make sure, you know, we understand a few things with vectors. So remember, a vector quantity has what? Magnitude, and it has direction. Okay? Yeah? So a vector quantity must start somewhere, it must end somewhere. It has direction indicated by an arrow. It will have magnitude. You know, you can put a magnitude in terms of a letter of the alphabet, or you can write it in terms of a column vector. Column vector looks like this. So column vector will look like this. XY. Where X represents from the starting point your horizontal movement, Y represents your vertical movement. Good? Always have that right angular movement. Good? And of course, your vector quantity must have direction. And you know, you state a vector as AB, put an arrow on top, moving from starting to ending, magnitude A. Similarly, you can write it as AB, moving from starting to ending, magnitude XY. Okay? But of course, there are a few things about vectors with AddMath. You need to know one thing very important is to make sure we understand what is called the triangle law. So key things, we need to make sure we know our triangle law. And the triangle law, of course, is if you have a triangle, you have A, B, C, and suppose we have vector AB, we have vector BC, and suppose vector AB has magnitude A, vector BC has magnitude B, and they want you to find vector AC. Good? What we're going to do is implement the triangle law. The triangle law is normally implemented when two vectors move in the same direction, once they follow each other. The two vectors that move in the same direction based on the arrows are AB follows BC. And when two vectors follow each other, what you always do is add them. So you have the addition of your vectors. So you're going to write vector AB plus vector BC. Those are the two that moves in the same direction, and you will always recognize where the two inner letters are the same, and that will give us, in that order, AC, moving from A to C. So vector AB follows vector BC. That's why with vectors you must have the directions on them. Of course, you have your magnitudes, which are A and B. And for us to implement this law, once we recognize two vectors moving in the same direction, we add them, vector AB plus BC. The two inner letters will always be the same. Once you apply this triangle law and you recognize where two vectors follow each other, the two inner letters are always the same, and you connect the outer in that order to give you AC. So therefore, AC, if I had to find the magnitude of AC in terms of A and B, the magnitude of AB is A, plus the magnitude of BC is B. So the magnitude of AC is A plus B. Alright? So this law is an important law known as the triangle law. Another thing with vectors you have to make sure you know is how to find the magnitude of a vector quantity. So suppose you have a vector, this vector AB, whose magnitude is represented as a column vector. And they want you to determine what is the actual size of the vector quantity. What's the actual size? So to determine the actual size or actual measurement for that vector quantity, this is what we use. You'll see that two parallel lines on either side of your vector quantity, which helps us to calculate the magnitude of the vector quantity. So I should put here to calculate the magnitude of a vector quantity. So those two parallel lines will allow that to happen, and the formula we use is the square root of x squared plus y squared. So you have to make sure you know that formula when it comes to vectors and finding the magnitude. Another thing you need to know with vectors is something called the unit vector. Right? So the unit vector is a vector whose magnitude is 1. So when you find the magnitude, like what we just did here using this formula, when you find the magnitude of a unit vector, it's supposed to be equal to 1. And the unit vector is just a fraction of a given vector, So if you have this vector AB, moving in that direction, the unit vector is just a fraction of this given vector. Just a little piece, a little fraction of that given vector. Alright? So suppose vector AB has magnitude xy, then the unit vector of AB, this little vector you see here, this little piece, this little fraction, will be written as what? Vector AB. We normally put out a little symbol on top to show it's a unit vector, and the formula is this. The fraction is written as 1 all over the magnitude of vector AB. That's a fraction. 1 all over the magnitude, the same square root of x squared plus y squared, multiplied by the vector AB. Alright, sometimes you see it as AB all over the magnitude. Yeah? So the fraction, the unit vector is a fraction of the given vector. That's a fraction, 1 over the magnitude times the given vector. Okay? So there's some key things you want to make sure you know. Calculating the magnitude, knowing what is the unit vector, understanding what's the triangle law, understanding what's a vector. And the last thing we want to make sure we know, before I do so, let's also make sure that the magnitude of your vector, if it's a column vector, we will see it also in terms of the units I and j. So if you have xy, you can also see it written as xi plus yj. Okay? So you can write this column vector in terms of the units I and j. So sometimes you see the magnitude written in this form. So if you see xi plus yj, it's the same as xy. You can write it like that. So either or. Good? And what we also need to know about vectors, and we'll get into our question next, is the angle between two vectors. Alright? This is very common. You're going to see this definitely tomorrow. They always bring it. So make sure you know how to find the angle between two vectors. Okay? So make sure you know this formula for the unit vector. This is something they bring regularly as well. You always see, you know, the modulus coming into play. Well, the magnitude. This is also known as the modulus, by the way. You call it the modulus. When you have the modulus, the result is always a positive result, right? So you see that regularly in a vector question, and sometimes you see your triangle law, yeah? So we also need to know how to find the angle between two vectors. So if you have, so the angle between two vector quantities. So to find an angle between two vector quantities, if I have a vector AB and I have a vector AC, or I have, let me erase all here. Or just to make it easier, let me put here, let's call this vector quantity A, and let's call this vector quantity B. And I need to find this angle between the two vectors. Good? Then I'm going to use something called a dot product. Tell me to find that angle. And of course, you know, when we're doing the multiple choice, because the multiple choice comes next, and I'll try to do a live going through some multiple choice questions. This will be A dot B. This is a dot product. You see this in your multiple choice is equal to the magnitude of A, or modulus of A, dot the modulus of B cos theta. So this here is an important formula. Make sure you know this for your vector question. Sorry, what you're going to see in your exam tomorrow. So the dot product. Alright? A dot B is equal to the modulus of A dot the modulus of B cos theta. Alright? So let's look at a question. Alright? Alright, let's start with this one. Okay, I'll probably try to do like two vector questions, and then we're going to move on to some trigs, alright? So let's start off with this one here. Let me erase all this. So after trigs, we do some, some quick differentiation, integration, and I'll look at a stats and probability, and that will be it for the night, right? Let's see how quickly we can get that done, right? It's now 10 o'clock, right? So let's look at this. So two vectors P and Q are such that P is equal to 8i plus 2j, that's the magnitude, and Q is equal to I minus 4j, that's the magnitude. They wanted to find P dot Q, right, which is this vector P multiplied by that vector Q, and they want us to state the angle between the two vectors P and Q, all right? So let's find out quickly. So this will be pretty straightforward. So you have your two vector quantities. One is P, whose magnitude is 8i plus 2j. Another is Q, whose magnitude is I minus 4j. And they want us to calculate PQ. Now, PQ is P dot Q is P multiplied by Q. Good? The dot represents multiplication. Now, you can multiply these two vectors in terms of I and J, but it may be easier to multiply them as column vectors. So you're going to convert this into A2, and you're going to convert this into, so this is P, you're going to convert Q into 1, negative 4. 1 is understood in front of this I, and negative 4 is understood in front of that J. So P dot Q is P A2 dot Q, which is 1, negative 4. You're multiplying those two vector quantities with the magnitude shown now as column vectors. And to multiply, this is what you're going to do. You're going to multiply 8 by 1 plus, you're going to multiply 2 by negative 4. So 8 by 1 plus 2 by negative 4. 8 by 1 will give us 8 plus 2 by negative 4 will give us negative 8. A plus by a minus is a minus. 8 minus 8 will be 0. So to calculate the product of P and Q, the dot product of P and Q is going to be 0. So just remember 8 by 1 in brackets, 8 in brackets, 1 in brackets, plus 2 by negative 4, 2 in brackets, negative 4 in brackets. And we simplify to get what we have there. Okay? Thumbs up. We clear on that? Straightforward. Thumbs up. Thumbs up. Yeah? So that's 1. So let's look at 2. We want to find 2, the angle between the two vectors. So we have those two vector quantities there. Good? And if you have to show those two vector quantities on a diagram, it's good to see it on a diagram and you know what's the angle. So let me show it on a diagram here. So if you want to just show a sketch to have a visual of the two vectors P and Q, you're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8. You're going to have 1, 2, 3, negative 1, negative 2, negative 3, negative 4. Good? Now, these two vectors are position vectors, meaning that they will start from the origin, O. And if it's 8i plus 2j, otherwise known as A2 as a column vector, what A2 means is not a point you're going to plot here. It means you're going to move from the starting point, which is the origin. You're going to move 8 to the right because 8 is positive. You're going to move 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8. And 2 means you're going to move 2 places upwards. So you're going to move 1, 2. Right? So this will be my ending position. This will be my starting position. And what I can do is draw a line from my starting position to my ending position, and this will be my direction from starting to ending, and that will be my vector P, whose magnitude is 8, 2. Yeah? The other vector, which is 1, negative 4, 1, negative 4. What 1, negative 4 means? It means you're going to move, because 1 is positive, you move to the right. So you're going to move 1 to the right, and negative 4 means you're going to move 4 places downward. So 1 to the right and 4 places downward. 1, 2, 3, 4. So this is where I'm going to start, and this is where I'm going to end. And this is my direction. Good? So what I want us to do, and this is my vector Q, whose magnitude is 1, negative 4. So just have a visual. So now they want us to state the angle between the two vectors P and Q. See this angle here? They want us to find that angle between those two vectors. So how are we going to find that angle between those two vectors? That is where we're going to now bring in the dot product or scalar product, right? Dot product. So it's going to be what? Using the dot product, is going to be P dot Q is equal to the modulus of P times the modulus of Q cos theta. P dot Q I'm not going to rework because we have that already as 0. We did that in part 1, so there's no need to go and repeat yourself. This is 0 is equal to the modulus of P, which is the square root of 8 squared plus 2 squared, dot, which means to multiply the square root of Q, which is 1 squared, plus negative 4 squared cos theta. So this becomes what? 0 is the square root of 64 plus 4 dot the square root of 1 plus 16. 1 squared is 1. Negative 4 squared is 16. It becomes 0 is equal to the square root of 68 dot the square root of 17. And because these two are surds, you can multiply the square root of 68 by the square root of 17 to give you 68 by 17 is 1156. So 0 is equal to the square root of 1156 cos theta. Don't forget your cos theta. Right? Let me make sure it's 1156 cos theta. So don't forget that cos theta following through. And therefore, to get cos theta by itself, because the aim is to find the angle theta between those two vectors. So what you're going to do, you're going to divide 0 by the square root of 1156 is equal to cos theta. 0 divided by the square root of 1156 will be 0 is equal to cos theta. And therefore, to get theta by itself, the angle between those two vectors, I'm going to remove cos, which comes across on the other side as cos inverse. So it's going to be cos inverse of 0 is equal to theta. And when we find cos inverse of 0, we are supposed to get what? We are supposed to make sure calculators back in degrees. When we use it in radians when we dealt with a sector, right? So cos inverse of 0 will give us 90 degrees. And this angle, and it looks like 90 here, yeah? It's looking like 90. So this angle here will be 90 degrees between the two vectors. Alright? So that will be 90 degrees that we have worked out there. Okay? So using this very important formula to find the angle between two vectors. Clear on that? Thumbs up, thumbs up. Alright? We can probably look at we have another part of this question, right? Part C. The position vector A is 4i minus 7j. Find the unit vector. They love to bring this. They show you how to find the unit vector in the direction of A. So remember what's the unit vector? The unit vector is just a fraction. So I'm erasing this. So the unit vector is just a fraction of this vector A here. All right? So if I have my vector A, the magnitude, I can write it as 4, -7, I can write it as a column, yeah? Then the unit vector is just a small piece or fraction of it, which I'm going to denote by A little hat. That's the unit vector. Good? So what's the unit vector? A hat. You know A is 4, -7, but A hat, which is your unit vector, is 1 all over the modulus of A. That's a fraction multiplied by the vector A. So just remember your fraction is 1 all over the modulus of A. And the modulus is what? 1 all over the square root of x squared plus y squared times A is 4, -7. Alright? And this becomes what? A hat is 1 all over the square root of, I'm replacing x with 4 in brackets squared plus -7 in brackets squared times 4, -7. This will simplify to become what? This becomes A hat is equal to 1 all over 16 plus 49 square root of 16 plus 49 times 4, -7. Which becomes A hat is 1 all over the square root of 65 times 4, -7. And what you can do now is multiply 1 over the square root of 65 by each of those inside of the brackets. So the A hat will be 4 all over the square root of 65 and 1 over the square root of 65 by -7 is -7 all over the square root of 65. Alright? So this here is the unit vector, the fraction of that given vector A. Alright? So you have the magnitude of the unit vector shown. And if you were to simply put this as the square root of x squared plus y squared, and you work it out, you're going to see what the magnitude is 1. If you find the magnitude of that vector, you're going to get 1. Alright? So, let me see if I can find another. Alright, let's look at this one here. Right, let's look at this one here. Alright, so I'm erasing here. And then we're going to move on to some trigs. And then we look at some differentiation, integration. Of course, you have your stats and probability, right? So let's see how much we can cover within the time, right? So the position vectors of 2 points A and B relative to a fixed point O are, you have OA and you have OB, position vectors. And I will always advise to have a visual. So with vectors in particular, it's always good to have a visual, right? So you set up a nice little sketch to help you. So where I and J represents the unit vectors in the X and Y directions respectively. They want us to calculate the magnitude of the vector AB. And in this question, you're going to see where the triangle law will come into play to help you, right? So set up a nice little sketch. You have vector OA, whose magnitude is 2I plus J, and you have OB, whose magnitude is 3I minus 5J. Remember, you can write that as what? 2, 1. You can write OB as 3, -5. Set up a nice little sketch to guide you. You have what? 0, 1, 2, 3, 4, 5, 6. You have 1, 2, 3, 4, -1, -2, -3, -4, Negative 5, right? Let's look at vector OA. Remember what is 2, 1? It's not a point you're going to plot, it's a movement. So it's going to be what? From the origin, that's my starting point O. I move 2 to the right because it's positive. 2 to the right of the starting point and 1 upward. So this is A. So I have my vector OA. Put your direction. You have your vector OB, which is what? 3, negative 5. So I'm moving 3 to the right, 1, 2, 3, negative 5 downwards. Because negative 5 means I'm moving down. Negative 1, negative 2, negative 3, negative 4, negative 5. That's B. So my vector will be from O to B. Good? But they want us to find the magnitude. And remember when they talk about magnitude, they want this. Calculate the magnitude of that vector AB. So what we need to do is find the vector AB first. So I'm going to connect A to B. So I need to find that vector AB first. So I'm going to put my direction. A vector quantity doesn't become a vector if you don't put the direction, right? You must put the direction. So I need to find AB first, and then I can find it. Right, is everyone hearing me? Is everyone hearing? Is everyone hearing me? No? Yeah. Right, good. Okay, so right, my apologies for that. Let's continue. Everyone hearing clearly? Okay. All right, so let's continue here. So with this question, we have to find the vector AB, but we're using a triangle law here, where one vector follows another. When they follow each other, we add them. So OA follows AB, so we add them, OA plus AB. And what we always do when we add them in that order, we always recognize that the two inner letters are the same, and we connect the outer in that order to give us OB. But remember what we are solving for. We are solving for vector AB. So this initial equation is the equation created from the triangle law by looking to see which two vectors move in the same direction. Once they move in the same direction, we add them, and the two inner letters will be the same. We connect the outer in that order to give us OB. But AB, which is what we want to find, is equal to OB minus OA. So vector OB minus vector OB. Vector OA, sorry. So vector OB, the magnitude is 3, negative 5. Subtract vector OA, whose magnitude is 2, 1. So we're going to get here 3 subtract 2 and negative 5 subtract 1. So 3 subtract 2 will give us 1, and negative 5 subtract 1 will give us negative 6. So what we have found here is the magnitude of vector AB as a column vector. So we got the magnitude of AB as a column vector, but to find this now, the magnitude of AB, the actual value of AB, we have to now use the square root of x squared plus y squared. So when they ask you to find the magnitude of AB, this is what we're using. If they ask you to find the magnitude of AB in terms of a column vector, then your answer remains like this. But if they ask you for the magnitude of AB to determine the actual size of the vector, we use this formula. So this is the square root of x will be 1 in brackets squared plus y will be negative 6 in brackets squared. This will be the square root of 1 plus negative 6 squared will be 36. And 1 plus 36 will give us a square root of 37. And we can interpolate, and to determine the magnitude, we use our formula, the square root of x squared plus y squared. Now the other part of this question asks us to find the angle AOB. So we want this angle here, AOB. So to find that angle theta, what are we going to do? We are going to simply use our dot product to get that angle between two vectors. So it's going to be vector OA dot, so vector OA. So the two vectors move outwards. So they must move outwards or move inwards. Both are moving outwards. So it's going to be vector OA dot vector OB is equal to the modulus of OA dot the modulus of OB cos the angle theta. So make sure you know this formula, because with your vector question tomorrow, you're certainly going to see where you have to find the angle between two vectors. So vector OA, the magnitude is 2, 1. Dot vector OB, the magnitude is 3, negative 5, is equal to the modulus of OA, which is the square root of 2 squared plus 1 squared, dot the modulus of OB, which is the square root of 3 squared plus negative 5 in brackets squared, cos theta. So let's multiply OA by OB. This is 2 times 3 plus 1 times negative 5. So 2 by 3 plus 1 by negative 5 is equal to the square root. 2 squared is 4 plus 1, so that becomes the square root of 5. And this will be dot. The square root of 3 squared is 9 plus 25. Cos theta. 2 by 3 is 6, plus 1 by negative 5 is negative 5, and this will be equal to the square root of 5 dot the square root of 34. Cos theta. Of course, 6 plus by a minus is a minus. 6 minus 5 is 1. And this will be, using surd, the square root of 5 by the square root of 34 will be the square root. Let's multiply 5 by 34. So 5 by 34, 1 is equal to the square root of 5 by 34 will give us 170 cos theta. And therefore, to get cos theta by itself, I have to remove 170. So I'm going to divide both sides by 170. 1 divided by the square root of 170 is equal to the square root of 170 cos theta over the square root of 170. So, of course, my two 170s will cancel out. And I'm going to get 1 all over the square root of 170 is equal to cos theta, and therefore to get theta by itself, I need to remove cos, which comes across on the other side as cos inverse of 1 all over the square root of 170. 170, sorry. So 1 all over the square root of 170 is equal to theta. So let's put that into our calculator. Let's see what we're going to get. This becomes shift cos, open bracket, 1 divided by the square root of 170, close bracket, and we're going to get 85.6 degrees. So this angle between OA and OB is 85.6 degrees. And that is what theta is equal to. So showing here where we're using our dot product, scalar product to help us to find an angle between two vectors. The use of the triangle law. Also remember when we talk about unit vectors, what we mean. When we see vectors in terms of I and j, note you can convert them into column vectors. Okay? And I will always advise with vectors, it's always good to have that visual. That visual is very important, alright? Okay, so let's move on now to trigs. So we're looking at trigonometry now. So with trigonometry, we want to make sure we remember some important identities. Good? So some important identities we need to remember for trigonometry. So for trigonometry, you Because with trigonometry, you're going to see where you have to know your identities. Those identities will help you to prove identities. Those identities will help you to solve trig equations. So what they bring in the exam will be, of course, proving identities, solving trig equations. We have to remember our compound angles, multiple angles. Of course, we have to remember the use of the quadrant analysis test, especially when it comes to solving trig equations. So with trigonometry, we want to make sure we can recall our identities. And remember, the key identities are tan theta is equal to sine theta over cos theta. So please remember that very important trig identity. Also remember sine squared theta plus cos squared theta is equal to 1. Another very important identity. Where you can make sine squared or cos squared the subject. So remember from this, you know sine squared theta is equal to 1 minus cos squared theta. So make sure you know this. This comes in the exam, or you see me regularly in most of the trig questions. Sine squared theta is equal to 1 minus cos squared theta, or cos squared theta is equal to 1 minus sine squared theta. So you have to remember this, very important. So these two you must remember. Yeah? So sine squared theta plus cos squared theta is equal to 1, and in both cases we can make sine squared the subject, or we can make cos squared the subject. So sine squared theta is equal to 1 minus cos squared theta, or cos squared theta is equal to 1 minus sine squared theta. And tan theta is equal to sine theta over cos theta. Alright? You also need to remember for that exam tomorrow, when it comes to trigs, will be your compound angles. So you have compound angles. And with your compound angles, if you have sine A plus B, this is a compound angle. Yeah? So for sine A plus B, we have to make sure we know the compound angle formula. So sine A plus B is equal to sine A cos B plus cos A sine B. Well, that's for sine A plus B. Sine A minus B is equal to sine A cos B minus cos A sine B. You have to remember cos A plus B. Cos A plus B is equal to cos A cos B minus, if it's plus, you're going to use the opposite sign, minus sine A sine B. Also remember cos A minus B, this is equal to cos A cos B plus sine A sine B. And we have to remember tan A plus B is equal to tan A plus tan A plus tan B all over 1 minus tan A multiplied by tan B. So you have to remember this very important compound angle with regards to tan. And of course tan A minus B is equal to tan A minus tan B all over 1 plus tan A multiplied by tan B. So these are some important compound angles. So your key identities, compound angles you have to remember, and you also need to remember your multiple angles. So multiple angles. Alright? So common multiple angles you're going to see in the exam will be sine 2a, for example. This is a multiple angle. Sine 2a is equal to, so please make sure you know this. You love to bring it. It is equal to 2 sine a cos a. Alright? So you should know what sine 2a is equal to. Make sure you know what cos 2a is equal to. Another very important multiple angle. And for cos 2a, there are 3 of them you have to know. 3 representations for cos 2a. Cos 2a is equal to cos squared a minus sine squared a. This is one of them. 2, cos 2a is equal to, we can replace this sine squared a with 1 minus cos squared a. So if we replace sine squared a with 1 minus cos squared a, we're going to get 2 cos squared a subtract 1. So cos 2a is equal to that as well. Cos 2a is also equal to, if we replace cos squared a with 1 minus sine squared a, you're going to get 1 minus 2 sine squared a. So there are 3 representations for cos 2a. You must remember for that exam tomorrow. They love to bring the cos 2a, they love to bring the sine 2a, and you have to make sure you also know tan 2a. Right? So tan 2a is the same as 2 tan a over 1 minus tan squared a. So you have to make sure you know those very important identities, multiple angles. So your multiple angles, your compound angles, and these are key trig identities. Okay? So when it comes to trigs, we have to know how to prove identities, we have to know how to solve trig equations. So let's look at let's look at a proven identity, yeah? Where we can apply some of our identities we see on the board here, right? Right, so let's look at this. Summary erase. Right, so they ask us to prove the identity 1 all over 1 minus sine x minus 1 all over 1 plus sine x is exactly equal to 2 tan x over cos x. Good? So, if we are asked to prove identities, the first thing we have to make sure we state is a proof. We consider one side, so we consider the more complex side. Let's consider the left-hand side. So consider the left-hand side, which is 1 all over 1 minus sine x, subtract 1 all over 1 plus sine x. So what we want to do is take what is on the left and we want to simplify it to achieve what is on the right. So this is proving identities. Proving one side is exactly equal to what is on the other. But to prove identities, you're going to use your identities along with your basic mathematical principles. So using identities, right, some of the basic identities along with your basic mathematical principles. So in this case, basic mathematical principles, once we see we have an expression where fractions are involved, the first thing we should do is find the LCM. Good? find the LCM. So you draw your line, and you're going to put as your LCM 1 of each. So you're going to put as your LCM 1 minus sine x, 1 plus sine x. That's the LCM. And then you're going to take our denominator and divide it in denominators, and we're going to divide it into our LCM. So 1 minus sine x into the LCM, 1 minus sine x into 1 minus sine x is 1. And I'm going to multiply, of course, so I'm going to be left with what? 1 plus sine x. And I'm going to multiply 1 plus sine x by 1, which will give me 1 plus sine x. Subtract. I'm going to divide 1 plus sine x into my LCM. My 1 plus sine x into my 1 plus sine x will be 1. And I'm going to be left with 1 minus sine x. And I'm going to multiply that by 1 in my numerator. So I'm going to put 1 minus sine x. But make sure you put that 1 minus sine x in brackets. Anytime you have a subtraction sign, good? And you have to replace something and there's a subtraction sign in front, especially that something has more than one term, you make sure you place that something within brackets. Good? Always, particularly if there's a subtraction sign in front of the term, you make sure if you have to replace it, you ensure it's placed within brackets. Especially if you have 2 or more terms, make sure it's placed within brackets. If you have a negative, and there's a negative sign or subtraction sign in front, if there's a negative number and there's a subtraction sign in front, you make sure you put that negative number in brackets. Good? To separate the two signs, because this subtraction sign in front is going to change the signs. So let's see what's going to happen. I'm going to now remove my brackets. This becomes what? 1 plus sine x. Negative 1 by 1 is negative 1. I'm removing my brackets now. And negative 1 by negative sine x is plus sine x. All over 1 minus sine x, 1 plus sine x. Alright, so we find the LCM first. We take our denominators, we divide it into the LCM. When we get our result, we multiply the numerator, we bring down our subtraction sign, we divide 1 plus sine x into the LCM, we get 1 minus sine x, we make sure 1 minus sine x is in brackets. Let's simplify. My 2 1's will cancel out to get 0. And sine x plus sine x gives me what? That becomes what? 2 sine x. All over 1 minus sine x, 1 plus sine x. Good? So what is going to happen here now? So we're still trying to achieve what is on the right. So let's expand what we have in the denominator. So let's expand. So don't be afraid. And with proven identities, don't ever doubt yourself, right? Once you know you're carrying out the correct steps, do not doubt yourself. So let us expand the denominator. In expanding, this is what? 1 by 1, 1 by sine x, negative sine x by 1, negative sine x by plus sine x. So I'm going to get 2 sine x over 1 by 1 is 1, 1 by plus sine x is plus sine x, negative sine x by 1 is negative sine x, and negative sine x by plus sine x will give me negative sine squared x. So never doubt yourself. Let's simplify what we have in our denominator. We're going to get 2 sine x over sine x minus sine x. This will cancel out, so that's 0. So I'm left with 1 minus sine squared x. But we're still not to what we have on the right. But when we look at that, don't ever doubt yourself. You know once you're applying the correct steps on the right track,
1 minus sine squared x is equal to what? If you look here, 1 minus sine squared theta is equal to cos squared theta. So 1 minus sine squared x is equal to what? Cos squared x. So you see why this identity is so important. So this becomes 2 sine x. I'm replacing 1 minus sine squared x with cos squared x. And I'm very close to what I need to achieve on the right-hand side of the equality relationship. So look at it here. So I need to get tan x over cos x. So look at this here. 2 sine x over cos squared x can be written as 2 sine x over cos squared x is the same as cos x by cos x. That's cos squared x. It's cos x by itself. And look at what's happening here now. We can write this as 2 cos x, 2 over cos x, 2 over cos x multiplied by sine x over cos x. So I can take this 2 sine x over cos x by cos x. That's a multiplication sign. Let me make that multiplication sign better. And I can separate it and write it as 2 over cos x by sine x over cos x. And look at it here. Sine x over cos x is what? Sine x over cos x is what? Tan x. Why it's so important to know your identities. So this becomes what? This becomes 2 over cos x multiplied by tan x. And therefore you can multiply 2 over cos x by tan x over 1 to become 2 tan x over cos x. And we have proven what is on the right. So at the end we always state, hence left hand side is exactly equal to right hand side. Always write that at the end after you have proven. And when you have proven your identity, you state, you put a box here which shows that you have demonstrated your proof. Okay? So this is proving your identity. You take one side and what you do is you want to simplify it to achieve what is on the other. But please don't doubt yourself. Apply your basic mathematical principles along with your knowledge of your trig identities to help you to prove one side is equal to the other. Alright? Let's look at solving a trig equation. Or in fact, let's look at a question where our compound angles can come into play. So let's look at this here. So are we all clear on what was done here? Thumbs up, thumbs up. So let's look at another example. Yeah? So let me erase. So let's look at this one and then we look at solving our trig equation, and then we move on into differentiation and integration. Alright? Yeah? And after differentiation and integration, we look at a quick stats, and some probability, and that will be it for the night. Okay? Yeah? So let's look at this very important question here. So we have given sine pi over 3, and it's important when you're dealing with trigonometry that you know your special angles. Pi over 3 is the same as 180 over 3, which is 60 degrees. 60 is a special angle. Pi over 4 is 45 degrees, which is also a special angle. Yeah? Pi over 6, which is 30 degrees, is a special angle. So 30, 60, 45 are special angles, and they have some key relationships that you must know. 3 key representations. Some in surd form. For example, sine of 180 over 3, which is 60 degrees. Sine of 60 is root 3 over 2. So you have to make sure you know these special angles, especially for 30, 60, and 45, which will help you, for example, in this question. And they love to bring this type of question here. So we have here so show it all using a calculator that cos pi over 4 minus pi over 3 all over sine 2 pi over 3 is equal to the square root of 2 plus the square root of 6 all over 2 the square root of 3. So be conscious of this type of question as well. Be conscious of it. Yeah? Now, we want to show that this is equal to this. And they gave us some important information here to help us. Good? This information is important to help us. This information here. Right? But when we look at this, once to show this is equal to that, we always again, once we are showing or proving something, we start by stating proof, consider one side. Let's consider the left hand side. So the left hand side we have cos pi over 4 minus pi over 3 over sine 2 pi over 3. Alright? Now understanding that what information is given, we have pi over 4, right? We have, which is 45, so we see pi over 4 here, sine pi over 4, cos pi over 4 is the square root of 2 over 2. We have pi over 3, so pi over 3, we see cos pi over 3, which is of course, that's cos 60 is a half, and sine pi over 3, which is sine 60 is the square root of 3 over 2. Now we see sine 2 pi over 3. Now 2 pi over 3, we don't have that here. Good? 2 pi over 3 is 2 by 180 divided by 3. 2 by 180 is what? 360 divided by 3, which is 120 degrees. We don't have a representation here of sine of 120 degrees or cos of 120 degrees. We're not seeing that there, even though 120 is a special angle. But we know 120 degrees, we have what? We have 60 degrees, not so? But we know 120 can be divided into what? 60 plus 60. Yeah? So let's represent this as, we're going to represent this as sine. So cos pi over 4 minus pi over 3 over sine 2 pi over 3, which is 120 degrees. We're going to separate it and represent it as what? Sine pi over 3 plus pi over 3. Pi over 3 plus pi over 3 will give us 2 pi over 3. And in using this now, we can use what they would have given us to assist us in showing what is on the left is equal to what is on the right. Okay? So remember, we're using what is given, right? They didn't give us any information for 2 pi over 3, but it's 60 degrees, and we know it's 120 degrees, sorry, and we know 120 degrees can be divided into what? 60 plus 60, which is pi over 3 plus pi over 3. But what this will now introduce is your compound angles. Remember we learned some compound angles? The compound angle formulae. So you're going to apply that now to the numerator and the denominator. So let's look at it here. This becomes what? And you have to know your compound angle formula. Cos pi over 4 minus pi over 3. That's the same as cos A minus B. Remember we learned that? Cos A minus B is what? Cos A, cos B, plus sine A, sine B. Alright, that's a compound angle for cos A minus B. This is cos pi over 4 minus pi over 3. So let's apply that formula. This becomes cos pi over 4 plus pi over 3 plus sine pi over 4 sine pi over 3. Good? All over. This is sine pi over 3 plus pi over 3. And we learn sine A plus B. And so we learn sine A plus B. We learn that compound angle formula. Right? Which will be what? Sine A cos B plus cos A sine B. We learned that. So this becomes what? Sine pi over 3 cos pi over 3 plus cos pi over 3 sine pi over 3. Good? So let's simplify this now using what we have here. Good? This becomes cos pi over 4 is the square root of 2 over 2 multiplied by cos pi over 3 is a half plus sine pi over 4 is the square root of 2 over 2 times sine pi over 3 is the square root of 3 over 2 over sine pi over 3 is the square root of 3 over 2 times cos pi over 3 is a half plus cos pi over 3 is a half times sine pi over 3 is the square root of 3 over 2. So let's break that down to see what we're going to get. Let's see if we're going to get what we have here. This becomes what? This becomes now the square root of 2 over 2 by a half will be the square root of 2 over 4 plus the square root of 2 over 2 by the square root of 3 over 2 and application of surd, we can say the square root of 2 by the square root of 3 is the square root of 6 over 2 by 2 is 4. 1 over the square root of 3 over 2 by a half will be the square root of 3 over 4 plus a half by the square root of 3 over 2 becomes the square root of 3 over 4. This will simplify to, once I have the same denominators, I can add my numerator. So this becomes the square root of 2 plus the square root of 6 all over 4. That's the numerator. All over the square root of 3 over 4 plus the square root of 3 over 4, the denominator remains the same and you add the numerator to become 2, the square root of 3 over 4. And therefore, to get the final representation, what we're going to do? We're going to represent this as what? This becomes, let's erase here. This becomes the square root of 2 plus the square root of 6 over 4 divided by 2 the square root of 3 over 4, and this becomes the square root of 2 plus the square root of 6 over 4 multiplied by 4 all over 2 the square root of 3. Now what's going to happen? The 2 4's, point of 4 is 1, point of 4 is 1, and we're going to be left with what? We're going to be left with the square root of 2 plus the square root of 6 all over 2 the square root of 3, which is what we want to achieve on the right hand side. So at the end, once you have achieved it, we state hence the left hand side is equal to the right hand side, and you put your box to show that you have demonstrated it. Okay? So you want to be familiar with this type of question where your compound angles can come into play. Okay? So your compound angles and the compound angle expansion formula, we'll have to bring it to make sure that you know it and you can apply it. Okay? Alright, let's look at solving a trig equation. So let's look at this. And then we're going to move on to some differentiation. I'll just show one more thing with the trigs, and then we move on to differentiation, integration quickly. Alright? So, let's look at this. So we want to solve that trig equation. So to solve that trig equation, what are we going to do? This here it is sine squared theta plus 3 cos 2 theta is equal to 2. And we want to solve that trig equation for 0 is less than theta is less than pi. Now, of course, given your answers to one decimal place. Now, when you're solving trig equations, they will always ask you to express your answer within a given range of values. And it's between 0 and pi, between 0 and 180. Good? And they have their representation in terms of radians. So sometimes they'll express the range within degrees, so you know that your answers will be in degrees. Or if not, they can express the range of values in radians, between 0 and pi. Good? So, in this case, we have to represent our answers in radians. So it means that your calculators, you have to make sure your calculator is in radians, okay? So you have to change your calculator to radians. And don't forget to change it back to degrees. So you wouldn't continue throughout your exam with the calculator in radians. So be careful. So, to solve this, what are we going to do? This here is a trig equation involving sine and cos. You can't solve a trig equation with two of these same, but two different trig identities, two different trig functions, I should say. You have sine and you have cos. You have to make sure you have the same trig identity or the same trig function, I should say, in order for you to solve that trig equation. So, let's get to one trig function. We're seeing here in this trig equation cos 2 theta. Cos 2 theta. Now I gave 3 representations. This is why you have to know all your angles and types of angles, right? I gave 3 representations for multiple angles. Cos 2 theta is a multiple angle. So I gave cos 2 theta is cos squared theta minus sine squared theta. Cos 2 theta is 2 cos squared theta minus 1. Cos 2 theta is 1 minus 2 sine squared theta. Good? So I gave 3 representations. So if I need to convert cos 2 theta, let me convert it strictly into sine. Let me convert this equation strictly into sine. That can be done easily. Yeah? By simply writing this as sine squared theta plus 3. I'm going to replace cos 2 theta. I'm going to replace this cos 2 theta with, if I want my equation strictly in terms of sine, I'm going to replace it with this. 1 minus 2 sine squared theta. Okay? Because I want my equation strictly in terms of sine theta. So therefore this becomes sine squared theta plus 3 and in brackets 1 minus 2 sine squared theta is equal to 2. Yeah? This becomes sine squared theta. Let me remove my brackets. 3 by 1 is 3. And 3 by negative 2 sine squared theta becomes negative 6 sine squared theta is equal to 2. Okay? Let me simplify. I'm going to group like terms. I'm going to put sine squared theta minus 6 sine squared theta plus 3. And I'm going to take my positive 2, bring it over as negative 2 is equal to 0. Because this here is developing into a quadratic equation. Remember, quadratic equation will always have variables squared. You're going to have an equal sign and everything is made equal to 0. So this becomes what? Sine squared theta minus 6 sine squared theta becomes negative 5. Sine squared theta plus 1 is equal to 0. Yeah? And what we can do here now is we can, 1, proceed to get sine squared theta as a subject. So the first thing, we see cos 2 theta. We can't solve a trig equation with 2 different trig functions, sine and cos. So we have to come to a one common trig function. So I decided to convert cos 2 theta into 1 minus 2 sine squared theta. So you must know what cos 2 theta is equal to. And there are 3 representations, so make sure you know them. I replace the cos 2 theta with 1 minus 2 sine squared theta. And of course I simplify what is on the left to come to what I have here. So to solve this trig equation now, what I'm going to do is to proceed to get sine squared theta as a subject. So this becomes what? Negative 5 sine squared theta. Positive 1 I bring across as negative 1. Yeah? I'm going to remove my negative 1/5. Sine squared theta is equal to negative 1 divided by negative 5. Yeah? So I'm going to remove this negative 5. So when I remove that negative 5 and I divide it both sides by negative 5, I'm going to get 1/5 on the right. So I'm going to get sine squared theta is equal to 1/5. And therefore, to get sine theta by itself, I have to remove this power of 2. So to remove a power of 2, you know you're going to find the what? Square root of both sides. I'm going to find the square root of both sides. So therefore, this becomes sine theta is equal to the square root of 1/5. And when I find the square root, and just keep this in mind, we have been trained to always consider the positive result, but you must also consider the negative result. So you put plus or minus in front of your square root symbol. Okay? So let's proceed to get all our values of theta that lies within that range 0 and pi. So we are going to start with, because it's plus or minus the square root of 1/5, we're going to write sine theta is equal to, we consider the positive representation. Positive is square root of 1/5. Yeah? So theta, to get theta now by itself, I have to remove sine, which comes across on the other side as sine inverse of the square root of 1/5. Sine inverse of the square root of 1/5, you go to your calculator, and what you're going to do this time, because they want your range of values or range of angles in radians, what I suggest you do at this point, change your calculator from degrees to radians. You put shift because you want your angles in radians. And when you get this first angle here, that will be known as your principal value, your principal angle. And then what you have to do is use your quadrant analysis test to get your secondary angles. But because they want your range of values in radians, let's get the principal angle in radians along with our secondary angles. So we change our calculator to radians. And I'm going to press now second function, sine, open brackets, the square root of 1 divided by 5, close brackets. And I'm going to get in radians as my principal value, right? My principal angle, 0.20, and they ask us to express the 1 decimal place, so let's put it to 0.2 radians. So I put that C there to represent radians. So that is my principal value. But remember, when you're solving trig equations, you're solving for both principal and secondary values. Don't forget that part. So this is where you're going to use what you call a quadrant analysis test. Right? And I'm sure we're all familiar with that. We're all familiar with all school teachers care. Good? All school teachers care. And because we are dealing with sign, and we deal with a positive principal value, sign is always positive in the first and second quadrants. But what we're going to do is ignore the first quadrant and focus on the second quadrant to get our secondary value. So the secondary value in this case will be, because it is in terms of radians, the secondary value, to get the secondary value, if it's sine and it's positive, it's going to always be 180 minus theta. But remember, you want your angle in radians. So we're going to change the 180 to pi minus theta. So we're going to use pi minus theta instead. And pi in that case will be 3.14. It's not 180 degrees, it's 3.14 because you want your angle in radians. So we're going to put here 3.14, subtract your principal value, which is this theta here, 0.2. So we're going to get our first set of values for theta. They are going to be 0.2 and 0.2 from 3.14 will give us 2.94 radians. Alright? So that's when we find or show sine theta is equal to the square root of 1/5, considering it positive. But remember, it's plus or minus the square root of 1/5. So you also have to consider the negative result. You have to keep that in mind. So you carry out all the steps, make sure that you convert your cos into sine, you simplify your equation, and of course you get sine theta is equal to plus or minus the square root of 1/5. You consider the positive, you remove sine, it comes across as sine inverse, you get your principal value, you use the quadrant analysis to get the secondary value. So now let's look at this here. Sine theta is equal to negative the square root of 1/5. Yeah? And therefore theta is equal to sine inverse of negative the square root of 1/5. So theta is equal to sine inverse of negative the square root of 1/5. And let's find that. Making sure your calculator is in radians. Shift sine, open brackets, negative square root symbol, 1 divided by 5, close brackets, equals. This is second function, sine inverse, open brackets, we have here negative square root of 1 divided by right, what you're getting when you put that into your calculator. Got it out? So we're getting here, alright, let me try this way. 1 square root of, right. So let's see. So I have second function sine right, good. Suppose I get negative 0 point, let me double check that again. Shift sine, open bracket, negative square root of, right, 1 divided by 5. Right, we're supposed to get negative 0.2. So be careful when you're using a calculator. We're using plus or minus. So if you're putting everything into the calculator, there's a plus or minus key on your calculator. So you're using that for the negative, to get that negative in front of the square root symbol. So sine inverse of negative the square root of 1 over 5 will give me negative 0.20 radians. Now that there is my what? Principal value. So I need to get my secondary values, and this is where we're using the quadrant analysis test to help us to get our secondary values. So we're using all school teachers care. So all school teachers care. And because we are looking at a negative principal value, and the trig function we're using is sine, this is very important to recognize where the secondary values lie. Because it is a negative principal value, we're dealing with sine. Sine is positive in A and S, but it is negative in T and C. Something you have to remember, it is negative in T and C. So in T, which is the third quadrant, it's always 180 plus theta. That's if it was in degrees, but you want it in radians, so it's going to be pi plus theta. And in the fourth quadrant, which is C, because remember sine is negative in C as well, the fourth quadrant, that is 360 minus theta. But because they want the angle in what? Radians, 360 is the same as 2 pi minus theta. So let's work out what is our secondary angle in the third quadrant. This will be 180, which of course using pi, so that's 3.14, plus, and you're not going to put plus negative 0.20, you're going to put plus 0.20. The negative sign here is just to indicate where sign is negative. So you're not going to put 3.14 plus negative 0.2. Just remember what the negative sign is there for, to recognize where sign is negative. So it's going to be 3.14 plus 0.2. And it's going to be 360, which is 2 pi. So 2 by 3.14 will give us what? 2 by 3.14 is 6.28. So that's going to be 6.28. Subtract, and you're not going to put subtract negative 0.20. Remember what the negative sign is there for? To indicate where sign is negative. So you're going to put 6.28, subtract 0.2 radians, right? 20 radians. And therefore, let's break it down to see what we're going to get. Theta is equal to minus 0.20, 3.14 at 0.2 will give us 3.34 radians, and 6.28 minus 0.2 will give us 6.08 radians. Good? But remember this part is very important. We got all the principal and secondary values that we can get. All the principal and secondary values. But they want your answer between what? 0 and pi. Which is 0. Pi is the same as 3.14. So you're looking at all the angles from the list of angles that we got, which lies between 0 and 3.14. And those angles are what? What lies between 0 and 3.14? I'm seeing one here. I'm seeing here. 0 and 3.14. That's about it, yeah? This doesn't lie between 0 and 3.14. This is more than 3.14. That's 3.34. That's 6.08. So your values of theta that you are looking at, which will satisfy this equation and falling within the range, are 0.2 radians and 2.94 radians. Alright? So this here is a trig equation. Many students have challenges with the trig equations, right? So you have to make sure that we understand. You see a question like that, you want to have one trig function you're working with, and make your conversions using your trig identities, solve your trig equations, come down to your principal values, use the quadrant analysis to get the secondary values, and then you check to see if it lies within the range given. Sometimes the range will be in degrees, sometimes it's going to be in radians. Alright? Okay, so right, just wanted to look at one more thing we can see. Right, and let's look at this one here. Let's look at this one, and then we're going to quickly move on to some differentiation integration. So what a time, but let's see what we can do. Alright, a right angle triangle XYZ has an angle theta where sine theta is equal to the square root of 5 over 5. Without evaluating theta, calculate the exact value, insert form if applicable of cos theta. So of course the trick with this, what we're going to do is use a right angle triangle to assist us. Okay? So if you have here this right angle triangle, this is theta. You have sine theta. There's the square root of 5 over 5. You know in your right angle triangle, sine theta, this is my angle, I'm assuming that this is my theta, acute angle theta. Sine is what? Sine opposite all over hypotenuse. So the opposite side, of course, is the side opposite the angle theta. So this is the square root of 5 here. And my hypotenuse is 5, which is here. Good? What I'm going to do now is use Pythagoras theorem so I can determine the remaining side of the right angle triangle. So using Pythagoras theorem, it's going to be the hypotenuse squared, 5 squared, is equal to the sum of the squares of the other two sides. The square root of 5 whole squared, and let's call it x squared. So this becomes 25 is equal to the square root of 5 whole squared is the square root of 5 by the square root of 5, which is the square root of 25, which gives 5, plus x squared. And therefore, what I can do, let me make x squared the subject, it's 25 minus 5 is equal to x squared, and therefore I'm going to get 20 is equal to x squared, and x is the square root of 20. So using Pythagoras theorem, I'm able to get x here, which I'm going to write as the square root of 20. So if you ask me, calculate the exact value, insert form if applicable. So if we're not gonna change this decimal number, we're going to leave it in terms of a surd. Remember the square root of 20 is a surd, right? So if you have to find cos theta, remember this is your angle, this side is opposite, this side is hypotenuse, this side is adjacent. And if you have to find cos theta is equal to side adjacent all over hypotenuse. The adjacent side is what? Square root of 20 all over the hypotenuse, which is what? 5. Easy too. 2 marks in the bag there. So use the right angle triangle, set up sine theta. You know what side is it? If this is your angle, you put theta here. This side is opposite, this side is hypotenuse. You know sine is opposite of hypotenuse. You use Pythagoras to get the third side, and now you're able to get cos theta. Let's see what the other part asks us to find. Sine 2 theta. Right? Sine 2 theta. So to get sine 2 theta, what are we going to do? And again, make sure you know the multiple angles, what sine 2 theta is equal to. Sine 2 theta is equal to 2 sine theta cos theta. That's what sine 2 theta is equal to, so you should know that. This will be 2 multiplied by sine theta, which is, you have that, the square root of 5 over 5, multiplied by cos theta, which is just worked out, the square root of 20 all over 5. So you're going to get what? This is the same as 2 multiplied by the square root of 5 by the square root of 20. Knowledge of surds, you can multiply surds, and this becomes the square root of 5 by 20. All over 25. The square root of 5 by 20 is the same as 100. So that's the square root of 100 over 25. The square root of 100 is what? 10. And 10 by 2 will give us 20. And 20 over 25, we can simplify that. 5 to 20 is 4. 5 to 25 is 5. So we have 4 pairs. Alright? So I'll shoot them with that. So let's move on now to some differentiation and integration. Alright? So differentiation, integration. So I'm looking at the time, and I'm not going to stay too long because I have to end the live shortly. Good? But let's see what we can do with our differentiation, integration. Let me see if I can touch on probably a quick stats and the probability. You know, there are a few questions I want to look at, but time is against me, right? So let's see. Now, so you know the calculus section is a very important section. That section, you know, you're dealing strictly with what? Differentiation and integration. So with differentiation, you know that's finding the gradient of a curve at a given point, right? The gradient of a curve at a given point. And we know with differentiation, we know that our differential coefficient dy over dx will always come into play if it's a y with respect to x. Good? If you're differentiating a function y with respect to x, dy over dx will be your differential coefficient, otherwise known as your derivative. So, note there are a number of important functions we have to know how to differentiate. You have your polynomial. So, the functions to differentiate. You have one, your polynomial, which is like an algebraic expression. You know, it might give you y is equal to x cubed minus 4x squared minus 6 over x squared minus the square root of x, something like that. That's a normal polynomial. So then you have to also know too, your composite function. So you have to know how to differentiate a composite function. And a composite function will be if you have y is equal to ax plus b to the power of n. Anything looking like that. That's a composite function. So if you have y is equal to 3x minus 5 cubed, that's a composite function. Yeah? So you have to make sure you know how to differentiate this. And to differentiate this function, we normally use what you call to differentiate it, the chain rule. So that's what you use to differentiate a composite function. And the chain rule is dy over dx is equal to dy all over du by du over dx. You always represent your function as a product of two differentials to get your answer. You also have to make sure you know how to differentiate your trig functions. Alright? So you have to know how to differentiate your trig functions. So of course you have to know how to differentiate y is equal to sine the angle. You have to know how to differentiate y is equal to cos the angle. And again, to differentiate trig functions, you have to use your chain rule. Alright? So when you differentiate, you represent your answer as a product of two differentials. Again, you represent the process to get your answer as a product of two differentials. You also have to know for differentiation, very important, the applications. Well, you have to know the second derivative as well. Or the second derivative. And this is where you're going to be using your differential coefficient d squared y over dx squared. Or sometimes we know it as f double prime x. Right? So when you're differentiating, of course, we know what our first derivative, we use dy over dx or f prime x. But the second derivative will be d squared y over dx squared over f double prime x. Good? You have to know as well for differentiation the applications. So applications of differentiation. And you can see any of the three, sometimes two of the three applications in your exam. You will see normals and tangents to a curve. So when you have a normal and a tangent, you have to find the equation of the normal and the equation of the tangent to a curve. You will also see what you call stationary points, and I love to bring this one, stationary points. And remember, for stationary points, dy over dx is equal to 0. That's a common thing with stationary points. Good? And you can also see something on rates of change. Alright? So rates of change. So we can bring a question on rates of change. So again, for rates of change, the chain rule comes into play here. So when we talk about rates of change, it's always with respect to time. Change with respect to time, and the chain rule will come into play. Alright? So you have to make sure you know how to differentiate a polynomial, a composite function, trig functions. Make sure you know your second derivative, and make sure you know your applications of differentiation. Alright? For integration, so I'll just find one or two examples, with the differentiation. Let's look at integration. Of course, look at one or two examples. And then we look at quickly. Of course, in that section, you're going to have kinematics too, right? So the kinematics, remember, you have to know how to draw your travel graphs, distance time, displacement time, velocity time graphs. You have to know those three, and you have to know as well something called SVA, right? S means distance, displacement, V velocity, A acceleration. All right. So we're going from S to V to A, that is differentiating. From A to V to S, you're integrating. Right? So you have to make sure you know that. Okay, so that will fall under the calculus section of the paper. So for integration, Right, so for integration, this is more or less the reverse of differentiation. Yeah, or it's called anti-derivative. Yeah, so the reverse process. And with integration, again, with integration, you're gonna be introduced, or you will encounter the integral symbol. So that's the integral symbol, so you'll see that in the exam definitely. And if you ask you to integrate some function with respect to x, or with respect to, if it's theta, with respect to theta, if it's with respect to t, you'll see the expression, in this case, with x involved. If it's with respect to theta, you'll see that theta is involved. If it's with respect to t, you're going to see that the expression will have t in it. Alright? Or forgot to include the process of differentiation, right? How we differentiate. So let me just put this as a note here. Okay, differentiation. How we differentiate, right? Remember, if you have y is equal to ax to the n, the process of differentiation is we begin with dy over dx. If it's y with respect to x, you take the power, multiply by the coefficient, you keep the variable x, and you subtract 1 from the power. Right? So this is key. Key thing that I forgot with what I've listed with your differentiation. The process of differentiation, right? How to differentiate a function. So with integration, it is the integral symbol. Of course, you're integrating this function with respect to x. The process of integration is you're going to, if you have ax in power of n, this is the process of integration. Of course, you're going to add 1 to the power, you're going to divide by the new power, and if it is one where there are no limits, which is otherwise known as the indefinite integral, you're going to add c. After you integrate, you always add c. So you add 1 to the power, you divide by the new power, and you add that constant c. Good? The definite integral is where you have limits. Right? You have limits. And note, the lower limit is always below, which is the lower value. The upper limit is on top. So when you integrate, note, once the limits are there, you are going to get your answer as a value. You get a value for your answer. So when you integrate, note, suppose you integrate this and you would have gotten f of x. You always maintain your limits throughout each step. And to get your final answer, you substitute the upper limit into the expression after you have integrated. Subtract, you always put the upper limit first. Subtract, you put the lower limit after. Alright? And of course, you're going to get a value for your result. So integration, this is the process. You add 1 to the power, you divide by the new power. This is your integral symbol, meaning you're integrating with respect to x. You're going to see this in the exam definitely. Remember, when you integrate with respect to x, once there are no limits, no a and b, then you add c after you have integrated. Don't forget that. Once the limits are there, you are going to obviously get a value for your result. And when you integrate in, note, you have to know how to integrate various functions. So the functions you have to know how to integrate are, so the functions we have to know how to integrate are 1, the polynomial. So again, an algebraic expression. You have to know how to integrate, again, your composite function. So if you have ax plus b to the power of n, if you have to integrate something like that, very important to note, you add 1 to the power, so this is a composite function, everything looking like that. So if you have to integrate something looking like this, good? You add 1 to the power, you divide by the new power, but you always, don't forget this important part, remember to multiply by 1 all over the differential of what's in brackets. This part is very important to include. You add 1 to the power, you divide by the new power, and you multiply by 1 all over the differential of what's in brackets, plus c. That's your composite function, you're integrating that. And 3, you have to know how to integrate your trig functions. Right? So you have to know how to integrate the trig function sine theta. Good? So you have to make sure you know that. So the integral of sine of an angle is negative cos the angle. So you have to make sure you know that. And you have to know how to integrate y is equal to cos the angle. Yeah? So key things we have to know. So the integral of sine the angle, sorry, cos the angle will be sine the angle. So if you are integrating sine, the integral of sine the angle is minus cos the angle. And there's something very important you have to remember with integrating trig functions as well. You have to remember to multiply by 1 all over the differential of the angle plus c. You have to remember that important part. Because if it's 3 theta, sine of 3 theta, if you don't include that part, you're going to get it wrong. Yeah? And similarly, the integral of cos the angle, the integral of cos the angle is sine the angle, multiply, don't forget that part, 1 all over the differential of the angle plus c. Alright? So the integral of sine the angle, when you differentiate theta, you're going to get 1, and 1 by negative cos theta is negative cos theta. You're going to get negative cos theta plus c. And the integral of cos the angle will become sine the angle plus c. Alright? So key things you have to remember when it comes to your trig functions and how to integrate them. You also have to know for integration, the applications of integration. Applications. So the applications of integration. So the applications, you have to know how to use integration to find the equation of a curve. You have to use integration to find the equation of a curve. You also have to know how to use integration to find the area under a curve. And if it's the area under the curve with respect to the x-axis, suppose this is A and that is B, and you need to find the area under that curve, then your formula for the area is the integral of y dx. Alright? Between the limits A and B. So very important for us to know when it comes to finding the area under the curve. You also have to know how to find the volume of revolution. This is another application, volume of revolution. And with the volume of revolution, your volume is found by using pi. So if it's the volume of revolution, so suppose it's with respect to the x-axis. So if it's revolving, because volume is applicable to a solid, if it's revolving, then it will look in 3 dimensions. That's all. Solid is in 3 dimensions. So therefore, that's why they talk about the volume of revolution. So the volume V is found by using pi. So don't forget, this is very important because you often see this as normally the last part, area and volume. The integral between the limits a and b, if it's with respect to the x-axis, y squared dx. Make sure you know that formula. You see these two? Make sure you know that when it comes to integration. Finding the area under the curve, finding the volume of revolution. Right? Major, major, major.